The last section we're going to take a look at is 6-2. So we're going to split it into 2 days. We'll do part today, part tomorrow, and then Thursday we'll have our test on everything from this week. All right, so 6-2 is on what we call unit circle trig. Okay, so I'm going to draw a diagram and kind of explain what the goal is in unit circle trig, and then we'll write that down. So the idea of unit circle trig is that you can hopefully move this and draw a circle, okay, just like that. Erase this. So I've got a circle with an x and a y axis. And in that circle, I can draw any size angle I want. So this is the angle that I'm going to draw. Just like that. Okay, so that angle we'll call theta, angle in red. And if we look at the terminal side of theta, it hits the edge of the circle right there. Okay. That point has an x value and a y value. That is the main goal in unit circle trig, to be able to figure out that coordinate. And then we do something with it. So no matter what size angle you draw, every angle between 0 and 360 degrees would have a unique x and y value on the circle. If you go past 360, then you're going to start repeating. Or if you go into negative angles, those are also repeats. But every angle on this circle has a unique coordinate. We are only going to be using unit circle trig to work with angles that are multiples of 30 and 45. If you have an angle that's not a multiple of 30 and 45, this is not something we would use, at least right now. We can use unit circle trig for a little bit more, but for now, just focus on 30s and 45s. Okay. So, any question on the idea of being able to find that coordinate? That's the goal. All right, let's write that down. So for certain angles, and again, certain angles mean multiples of 30 and 45, we can draw them in the unit circle. And then I just want to reword that part. And then determine the coordinate where the terminal side intersects the circle. This coordinate will have an x and a y value to it. You need both. So determine the coordinate. I'm just going to put in parentheses above it. The coordinate will have an x and a y value where the terminal side intersects the circle. Once you have the x and the y value from the coordinate, those are the two numbers that are going to be important because they will allow us to be able to find what's called the 6 trig functions of the angle that we drew. Okay, I'm going to talk about what the 6 trig functions are in a minute. So the x and the y value from the coordinate allows you to find the 6 trig functions of the angle. So when you're dealing with unit circle trig, if they give you a problem with an angle, your goal is you have to figure out the coordinate that represents that angle. Okay. That's the most important thing that you need to work with. You need to know a location, not the size of an angle. So if they give you the size of an angle, you have to convert it to a location on a circle. Now, since we're dealing with a unit circle, how big is a unit circle? Yep. What is 1 unit?
Radius.
The radius, yep. So when you're dealing with a unit circle, we're dealing with a circle with a radius of 1. We could do this on a different size circle, but it adds a little bit of complexity to it. So if we stick with a unit circle, that's going to be the simplest way to do this. All right. So now let's look at the 6 formulas that are going to use the x and the y value from the coordinate. Okay, so these are the first 3 trig functions, okay, and their names are sine, cosine, and tangent. All these have 3-letter abbreviations, and generally, the abbreviation is the first 3 letters of the word. And for those 3, it is sine, cosine, and tangent. Okay. This right here, that is your argument. It's what you are plugging into the sine function. So if I did something like, say, sine of 30 degrees. 30 is what we would call the argument. It's what's being plugged in. And when you plug something in, the argument is always an angle. That's the only thing you can take the sine, the cosine, or tangent of an angle. You can't do it of the length of a side in a triangle. You can't do it of any other number unless that number is an angle. The angle can be in radians or degrees. So when we start pressing sine, cosine, and tangent, it's important that we look at this mode up here. Okay, the mode right at the end where it says, well, second thing from the end. You can be in degrees or radians, but it depends on the question. If you need to change the mode, you can press mode, and there's 2 options, radians and degrees. The whole idea of unit circle is we don't need the calculator as long as the angle we're working with is a 30, a 45, or a multiple of a 30 or 45. If we were dealing with an angle like 16.5, well, we're not doing unit circle trig with 16.5. And that's something we would have to type in on the calculator. So tomorrow we'll get to the calculator and how you use that. Okay, but we really actually aren't going to really use the calculator much today. So when you define the trig functions, if you're familiar with like opposite, adjacent, and hypotenuse, that's trig as well. Okay? But the difference is that's right triangle trig. Okay? It's connected to this. It's actually just a different way of thinking about the same thing. But we're going to be thinking about this from the perspective of what's called a unit circle. So we're not going to use the words opposite, adjacent, and hypotenuse in the definitions of trig functions. Okay, so 6 trig functions. If I ask you for the sine of an angle, you have to find the coordinate that represents that angle, and then I want to know the y value. If I ask you for the cosine of an angle, you need to find the coordinate for the angle and give me the x value. If I ask for the tangent, now you need both. It's the y value divided by the x value. So that's our first 3 trig functions, and we have buttons for those 3 on the calculator. Sine, cosine, tangent. All right. Does anybody know the next 3? What those names are? Yeah?
Secant, cosecant, and cotangent?
Yep. Secant, cosecant, and cotangent. They also have abbreviations, and I told you the abbreviation is usually the first 3 letters, but not for cosecant. Anybody know why that one's different? Yep.
Would be the same as cosine?
Yeah, it would be the same as cosine. So they just use the first letter of each syllable. Cosecant. CS. And I wrote them the way that I did because there's a connection between sine and cosecant, between cosine and secant, and between tangent and cotangent. The connection is they are what we call reciprocals. Okay? So if you know the sine, all you have to do is flip it, and that is the cosecant. So if we know the sine is the y value, what do you think the formula for the cosecant would be? Yeah? 1 over y. And same reasoning for secant. What do you think the formula for secant would be? Yep.
1 over x.
1 over x. It's the reciprocal of cosine. And how about the formula for cotangent? Yeah.
X over y.
X over y. So those 6 formulas, they only use 2 different numbers, the x and the y value for the coordinate, and that's all the different ways that you could use them. Any questions on any of those definitions? Now, which one of the 6 that you need to use? Well, it depends on the question. If the question says, find the 6 trig functions, well, then you're doing all 6. If the question said to just find one of them specifically, you could just do that one. All right, we're going to talk about different angles on the unit circle. But the first 4 we're going to talk about are the quadrantal angles. And those are the angles that are multiples of 90. 0, 90, 180, and 270. We should be able to figure out the coordinates for those 4 pretty easily. Okay, so let's say we have our xy axis. Let's put a circle on it. And as we go counterclockwise, starting on the positive x-axis, that is 0. And then going up is 90, continuing is 180, and at the bottom is 270. So let's start with the coordinate for 0. Anyone have a guess, knowing that that's a unit circle, what the coordinate would be for the dot at 0 degrees? Yep.
0, 1.
So 0, 1, that's going to be 90.
1, 0.
1, 0. Yep. So 1, 0 is the coordinate for 0 degrees. Never changes. It's always the same. We just did 90. How about 180? What would be the coordinate for that?
Negative 1, 0.
Negative 1, 0. And how about the coordinate for 270? Yep. 0, negative 1. Okay, so those are the 4 angles that we're going to start out working with, those 4. The other ones, which we will get into a little bit later on, are the 45, the 30, and the 60. And you can have a 45, a 30, and a 60 in every quadrant. So by the time we're done the unit circle, you'll have 16 different points. 3 blue dots in each quadrant and the 4 red ones. 16 different points that you should know how to work with. Also, if you notice, the 3 blue dots for the 30, the 45, and the 60, they're not equally spaced in the quadrant. Because the gap between 0 and 30, that's a 30 degree gap. The gap between 30 and 45 is 15, and between 45 and 60 is 15. So we're actually missing 2 angles here. Anybody know what 2 angles we're missing? Yep.
15 and 75.
Yeah, we're missing a 15 and a 75. The green dots are not going to be something we talk about for quite a while. Okay, we'll get to those in a later chapter. But anything that's a multiple of 15, we can technically do it, but we need to know a little bit more about the unit circle first. Okay? So red dots are what we're going to focus on first. Blue dots we'll get to in a little bit. Green dots are a couple chapters away. Okay. So how do we do unit circle trig? So the goal of unit circle trig, we're trying to figure out the sine, the cosine, the tangent, secant, cosecant, and the cotangent. Step one, you have to have a coordinate that represents your angle. So find the coordinate that corresponds to your angle. Now, sometimes they'll give you the coordinate. In the first problem that we're going to do, I've already given you a coordinate. So that step's already done. In the second one that I do, we're not going to have the coordinate. Okay? I've given you the angle. Now you've got to figure out the coordinate first. But we just talked about that. Once you figure out the coordinate, then you can plug those x and y values into whatever formula they want you to find. We're going to do all 6. So that means we're going to have 6 calculations per question. When we get to tomorrow, we won't be doing all 6 every single time. But to start out with, we will practice all 6. Now, a couple things can happen when we do unit circle trig. Square roots will be involved at some point. And if we ever end up with a square root in the bottom of a fraction, we need to fix it. The other thing that can happen is we can get fractions divided by fractions. We don't want to leave answers like that either. Okay, so we always have to simplify as much as we can. And those are the 2 things that are going to happen. Okay, so any questions on the 2 steps? Let's try a problem. So the first problem says that they've given you a point that represents an angle, and they want you to find all 6 trig functions. Now, you don't need to know what angle this is. You should know, from what we just did, but you don't need to know. We have the coordinate. That's the most important thing you need, and we're just going to plug the x and the y values into the 6 formulas. Since they didn't give me the angle, I'm just going to represent the angle as theta, and I'm using its location to figure out everything I want to know. So let's start with sine. What's the formula for sine? Yeah, it's the y value. What's the y value that represents this angle? 1. This angle is located, its terminal side is located at 0, 1. So the y value is 1, and that's it. Let's do the cosine. What's the formula for cosine? Yep, x. And what is the x value of the location of this angle? 0, yep. And when I say the location of the angle, I mean the point where the terminal side of the angle hits the circle. That's what I mean. And let's finish up the 3 that are on the left. Tangent. What's the formula for tangent? Yeah?
Y over x.
It's y over x. What do you get if you divide y by x here? Yeah, we say undefined. You can't divide by 0. Because this would be 1 divided by 0. All right. We've got the first 3. Now we'll do the next 3. What's the name of the trig function that's the reciprocal of sine? Yep.
Cosecant.
Cosecant. And since it's the reciprocal, all we have to do is take the answer for sine, flip it, and we have cosecant. So what's going to be my final answer for cosecant? Yeah?
1.
1. There are two numbers you can flip and they stay the same. That's one of them. 1. What's the other number you can flip and it stays the same? Yep.
-1.
-1. Yep. All right. Next one. What's the name of the function that you get when you flip the cosine? Yep. That's it.
Secant.
Secant. And what's the secant of my angle, which is represented by that coordinate, going to be?
1/x.
So, yeah, what would you put right here?
So undefined.
So, tell me one more time, what did you say?
1/x.
And so your final answer would be?
Undefined.
Undefined, yeah. It's undefined. Okay, because you're flipping 0. Anytime you flip 0, you get undefined. And the last function. Yeah, just go ahead. Cotangent. And what would the cotangent of our angle represented by that coordinate be? Yeah, it would be 0. Because you are flipping the tangent. Tangent was 1/0. When you flip it, it becomes 0/1. 0 divided by 1 is 0. Okay. And that's the 6 trig functions of theta. What is theta here? And you don't have to know this, but I hope you do. Yeah?
An angle.
Which angle in particular?
The one in the center.
I'm looking for a number.
Number.
Yeah.
30.
It's not a 30. So the coordinate
Oh,
is a
it's
coordinate
90.
we've
It's
seen
90.
before.
It's 90.
Yeah, that's a 90. We are going to do 30, probably tomorrow. But yeah, that's the coordinate for a 90-degree angle. You don't need to know that. You should know it. But you can do everything without knowing that it was a 90. Yeah. All right, let's look at the next one. What's different about that coordinate? 1/2, comma, √3/2. Yeah?
They're fraction.
Okay, we've got fractions. So based on what I've shown you so far, you know that that's not the coordinate for what? You might not know what it is the coordinate for, but you should know what it's not the coordinates for. Yeah?
For 0 degrees or 90 degrees, 270 or 180.
Right, that's not the coordinate for any of the quadrantal angles. It is the coordinate for something else, but for now you don't need to know what it's the coordinate for. Okay, but it is something. So we're going to find our 6 trig functions. Again, we don't know what angle that represents, and maybe this time you really don't know. Okay, so we'll just call the angle theta. So if we took the sine of our mystery angle that we don't know, but we do know where it is, what would be the sine of theta? Yeah? √3/2. So your sine is √3/2. What's the cosine? Yeah? 1/2. Sine and cosine are the easiest two to do because you don't have to flip anything and you don't have any division you have to do. Fractions over fractions. Okay. So let's go to the tangent. What's the formula again for tangent? Yeah.
Y/x.
It's y/x. So it's √3/2. Actually, I'll just do it right here. √3/2 divided by 1/2. What's going to happen when we divide √3/2 by 1/2? Yeah?
It's gonna double.
It's going to double, yeah, right? It's going to double. So what you're really doing is you're taking what's in the bottom, you're flipping, and multiplying by what's in the top. So you're going to multiply it by 2. So what does that mean is going to happen to these 2's? they're going to cancel out. Okay? If you flip and multiply, you're going to have a 2 in the bottom and then a 2 in the top. So the 2's are gone. What are you left with for the tangent if you simplify?
Root 3.
It's just root 3. Yep. Okay, so there's our first 3. And now let's do all the reciprocals. Okay, cosecant. Right, Maggie, how do you find the cosecant?
It's 1 over 1.
Okay, which means what based on the side?
It'd be 1 over root 3.
So what do we do? What's the easy way to find the cosecant? Yep.
Just flip the fraction.
Just flip the sign, yeah. You just flip it. So what do you get if you flip that? Yeah.
2 over root 3.
We get 2 over root 3. But I talked about that. We can't leave that. So now what do I have to do to fix that? Yep.
You have to multiply the top and bottom by root 3.
Yep. Multiply top and bottom by root 3. And what will that give you for final answer for cosecant? Yep.
2 times root 3 over 3.
Yep. 2 root 3 over 3. Perfect. All right. Let's do the secant. Okay, what's the secant of our angle going to be? How about, yeah, 8?
2.
2. Just take the cosine and flip it. This time, because the cosine didn't have a root in it, when you flip it, you don't have to deal with any roots. All right, and the cotangent. Kyle, what's going to be my first step to get the cotangent?
1/2 over root 3 over 2.
Okay, so you can go all the way back to the definition, or you can just
Flip the tangent.
flip the tangent, yeah. Because we've already done some simplifying. We already got rid of the 2's. So if we go back to the definition, we're going to have to simplify it again. So let's use what we already have, root 3. And what do you get if you flip root 3?
1 over root 3.
Yeah, starts out as 1 over root 3. We have the same issue as the cosecant. We need to fix it. And what do I get when I fix that so the root is not in the bottom? Yeah.
Root 3 over 3.
Root 3 over 3.
Yeah.
Okay. Other thing you might have noticed here is we're not using decimals. Okay? We're always writing every answer as an exact answer. It wasn't as big of a deal with 1 and 0 in the coordinate because we didn't have any fractions. But when we do start to get fractions with roots, no decimals. No decimals. All right. Any questions on that one? Okay, let's try this one. Find the 6 trig functions of 90 degrees. Okay, what's different about this one? Definitely something different, Emma.
We're using the degrees instead of the fractions and coordinates.
Right, you need the location of the terminal side of that angle. You don't need the angle. The angle will help you find what you need, but it's not what you need to do all the definitions. So we can make a sketch. Hopefully for 90 we can start to memorize it. Where's 90 on the circle? Yep, it's right at the top. And what's the coordinate at the top?
0, 1.
0, 1. So now we're doing the 6 trig functions, and we're using the coordinate 0, 1, but we already did that. So example 2 is the same as example 1a. Same thing. Any question why it's the same as example 1a? The only extra step is they gave you the angle. You had to figure out the coordinate, but then you'd go through all the same steps. All right, let's try this one. The 6 trig functions of 270. What do we have to do first on this one?
On the ordered pair.
Yep, find the coordinate that represents where the terminal side of that angle hits the perimeter of the unit circle. And what is the coordinate for 270? Yep.
0, -1.
Yeah, it's at the bottom. 0, -1. So let's go through all our 6 trig functions. And hopefully for the quadrantal angles, it should get pretty quick. In general, unit circle trig is the kind of thing that the more you practice it, the faster you'll get at it. And I know if you take calculus next year, you may have like a quiz at the beginning of class one day where they give you 20 of these unit circle problems to do and give you like 2 minutes. So if you have to calculate every one and you're spending like 30 to 40 seconds doing every one, you'll never get 20 done in 2 minutes. But if you have the unit circle memorized, you can give 20 answers in probably 40 seconds. Maybe it takes you 1 to 2 seconds per problem. It's basically just coming from memory. The only thing slowing you down is actually writing it, but you're not having to think about it. All right, so let's do these 3. What's the sine of 270? Yeah.
-1.
-1, cosine? Yep.
0.
0. And the tangent? Yep. Undefined. Okay, so there's the first 3. How about, Hunter, can you give me the last 3?
Cosecant would be 1 over, would just be 1, or so no, it would be -1.
-1. Yep.
Secant would be 0.
Well, it can't be the same as the cosine, because when you flip 0, you don't get
yeah.
0. That one's undefined. Yep. And the cotangent of 270?
Wouldn't that be 0 over -1?
And what would that be?
0.
0. Okay, so that's the 6 trig functions for 270. Any question on that one? All right, let's try this one. 6 trig functions of pi. Okay. What's a little different about this one than any of the ones we've done so far? It's the first time we've seen one like this. Yep.
It's not an angle or an ordered pair.
Well, it's got to be one of those, because those are the only 2 things I could give you to work with. Yep.
It's in radians?
Yeah, that's an angle, but it's in radians. So we either have to get used to thinking where pi is on the circle, or you have to get really fast at changing radians to degrees and then visualizing where it is on the circle. Either way. So where is pi? Yeah?
180.
Yeah, pi is 180. That's right there. So what's the coordinate for 180 degrees? Yep, please. -1, 0. I just want to see, did we already do -1, 0? No. No, I guess that's not one we've done. We did 0, -1. Okay. So let's go through all the values. Sarah, what's the sine going to be? Just say it again? 0, yep. Sine is 0. Kylie, how about the cosine?
-1.
-1. Yep. And how about Jace, what's the tangent? What's y divided by x?
0.
0, yeah. So it's 0 divided by -1. Okay, Reese, how about the cosecant? Yeah, that's undefined because you're flipping 0. Good. How about the secant? Yep. -1. And how about the cotangent? Yeah,
Undefined.
that's undefined. So the only time you can get values that are undefined is in a quadrantal angle. Because to get undefined, you have to have a 0 in the coordinate. And if it's not a multiple of 90, it will not have a 0 in the coordinate. It'll be off axis. Any questions on that? All right, let's try this one. 6 trig functions of 7 pi over 2. What might we want to do first here that could make that a little easier for us to visualize? Yep.
Put it in degrees.
All right, let's put it in degrees. What do you multiply by to change it to degrees?
180 over pi.
Yep, 180 over pi. Pi's cancel. And 2 goes into 180 90 times. So you're left with 7 times 90 degrees. How much is that? About, Eileen, what's 7 times 90 degrees? 630. Now, I still don't particularly like that angle. It's better, I guess, because it's in degrees. So what can we do with that? Yeah?
Minus 360 from it.
Right, we've gone around more than once. We don't care about how many times we've gone around. Not for unit circle trig. We just need to know where the terminal side stops. So if you want to make that angle easier to think about, subtract 360 from it. Oops. Minus 360. You get 270. Have we already done 270 degrees? Yeah,
Yes.
that was example 3. So the question I'm asking now is exactly the same as example 3. All right, and let's try this one. Find the 6 trig functions of -90. What could we do with -90 to make that a little easier to think about? We don't like to have to think of angles bigger than 360. We don't have to think of them smaller than 0. We want them between 0 and 360.
Get the coterminal angle at 360 to it.
Yep, exactly. And what angle is coterminal with -90 and between 0 and 360? 270. This is the 3rd time I've asked the same question. So even though it looks different, example 6, example 5, and example 3, all the same thing. So what you can see is there's not a lot of variation with these problems. If you're just sticking with the quadrantal angles, there's only 4 different questions I could ask. I could make the question look different by putting -90 instead of 270, but I'm really not asking anything different. I'm just wording it differently. So any questions on that? Okay, so. All right, so we've looked at the beginning of unit circle trig, and we know what the definitions are, and we know how to find the coordinates of angles that are 0, 90, 180, and 270. In part 2, we're going to start by looking at the angles that are off the axis. We're going to look at the 30, the 60, and the 45. Those are the 3 angles that are clustered kind of in the center of quadrant 1. If we can get comfortable working with the 30, the 45, and the 60, then working with any multiples of 30, 45, and 60 is extremely easy. So it might seem like there's a lot to have to memorize, but the quadrantal angles, those are easy. They're all 1s, 0s, and -1s. These three are really the only three you're going to have to memorize, because then when you get to multiples of them, it's going to be the same coordinates, just reflected into quadrants 2, 3, and 4. And when you reflect a coordinate, all you do is make one of the numbers negative, or both, depending on the quadrant. So other than a negative sign, there's nothing more difficult about working with multiples. Today we're going to look, I think, just at the 45, and then tomorrow we'll do everything else. The 30s, the 60s, the multiples, and we're going to start talking a little bit at the very end about trig identities. So trig identities is something we're going to spend at least 4 days on, maybe 5. It's a big topic. Today, or probably tomorrow, is just kind of an introduction to it. I've actually already shown you some trig identities in the last section. I didn't call them trig identities, but the fact that you can flip sign to get cosecant, that's called a reciprocal identity. That means it's true all the time. Any angle that you have the sign for, if you flip it, you will always get the cosecant. Okay, that's an identity. Right, so we'll talk more about those tomorrow. All right, so let's look at our diagram. And what I've drawn this time is an angle that has a terminal side at a 45 degree. So here's your initial, here's your terminal, and the goal is to figure out the x and the y value for that coordinate. Does anybody have a thought about the x's and the y values? Maybe not even what they are, but maybe some kind of connection between the x and the y value in a 45? So think about if you started at the origin and you wanted to get to 45 degrees. Okay? You have to move horizontally and then you have to move vertically. So if we made a certain shape there, that may help us to visualize the length of each movement, horizontally and vertically. Anybody have a thought what shape we could draw here? Yeah?
Triangle?
All right, how would you make your triangle?
You would start at the origin and like go across until you reach like the outer line of the circle, and then go up.
Okay, so I already have a couple points at the origin that go out to the edge of the circle. So I already have two of those. So I don't think we have to draw anything else from the origin to make a triangle here, because we've got those two. But there is something else we need to draw. Yeah?
Draw a line straight down from where the line intersects the circle.
Which side of the angle?
The terminal.
Yeah, draw a perpendicular from where the terminal side hits the edge of the circle down to the x-axis. So now you've just made a triangle. Okay, so what we're trying to figure out is, starting at the origin, how far over do you go? And then how far up do you go? The length of those two sides of the triangle are the x and the y value of the coordinate of 45 degrees. How far over? How far up? So any thoughts about the x and the y now? Okay, so what kind of triangle did I just draw? There's several names. We'll see if you get the right one. It's a right triangle, I'll tell you that. I'm not looking for that. So it is a right triangle. Looking for something else, yeah?
45, 45, 90.
So yeah, it is a special right triangle. It's a 45, 45, 90. Can you tell me more about a 45, 45, 90? Yeah?
I believe both of the legs are x in length, and then the hypotenuse is like x times the square root of 2.
All right, so there is a special connection between the sides in a 45, 45, 90, which you would learn in geometry. We're going to pretend we don't remember that connection, and maybe some people really don't. So we're going to figure out what I'm trying to have you figure out without having to use that knowledge. But yes, there is a connection there that you're talking about, which is good to know. But I'm looking for something else about this triangle, another name for it. It's a special right triangle. But yeah?
This isn't like the triangle thing, but wouldn't x and y be the same?
Yes, that's what I was trying to get at earlier. That is the connection between x and y. They are the same, but I was trying to help you because we seem stuck on that. What kind of triangle is this? And that tells you why x and y are the same. Yeah? It's isosceles, yes.
You're so smart, Alex.
So, because it's isosceles, x and y are the same, and that's what I wanted you to finally get to. Okay, I'm going to draw the same triangle. I'm just going to make a bigger version of it down here. Are there any sides in this triangle that we already know? Yeah?
Hypotenuse
Yeah, what is the hypotenuse?
1,
Why?
because it's the radius of the circle.
Right, it's the radius of the unit circle, which is 1. Now, the other two sides we know are the same. We don't know what they are, but they're the same. So let's call the bottom side x. What would we call the height? Yeah? X. You'd only use different letters if they were different values. They're not different values. So if you want to use any two letters you want that are the same, that's fine. Now, how many different variables are we using to label the sides of that triangle? Yeah,
1.
just one. There's only one variable there. So if we can set up an equation that relates this, this, and that, we can easily solve it because it will only have one letter in it. It'll use that letter more than once, but it's still just one letter. What would be an equation we could use that connects these three values? Yeah? Yeah, Pythagorean theorem. So what would the Pythagorean theorem be using the three values that I have circled?
X squared plus x squared equals 1 squared.
Yep. X squared plus x squared equals 1 squared. Now solve for x, and then you'll know how long the base of the triangle is and the height of the triangle, which means you'll know your coordinate. And then once we figure this coordinate out, we don't ever want to have to go back and figure this out from scratch again. Right? We want to just memorize the coordinate once we know it. All right, so combine our like terms. X squared plus x squared gives me 2x squared. 1 squared gives me 1. X squared is a half. And how are we going to get x by itself?
Square
Claire?
root.
Yep, and how do you take the square root of a fraction without a calculator?
That's a good question.
Good question. That's what they pay me for, to ask the good questions. How do we take the square root of a fraction? Calculator. I've already addressed that. No? We're not sure how to take the square root of a fraction? Okay, so to take the square root of a fraction, you need to square root the numerator and the denominator separately. You have to square root both. So when we take the square root of the top, that's fine. We just get 1. And what's the square root of the bottom? Root 2. But we can't leave it like that because we ended up with a root in the bottom. So what does 1 over root 2 simplify to? Yeah.
Root 2 over 2.
Root 2 over 2. So we just solved for x, which is the length of the base and the height. So now, if we go back up to our diagram, we should be able to write down the coordinate for 45. What is the coordinate for 45 degrees? Yep.
Root 2 over 2. Root 2 over 2.
Root 2 over 2, root 2 over 2. Because it's isosceles, we already knew they had to be the same. And that's the two values. So now if you have to do any type of unit circle trig, and they say find the 6 trig functions of 45 degrees, your first step is to remember that that is the coordinate for 45 degrees. So now, if we went over here, let's pretend that that dot is a reflection over the y-axis, perfect reflection. What angle would that be? If that dot was reflected over the x-axis, and pretend that the terminal side is going through that dot now. So there's your new angle now. And I'm asking how big this angle is right here. That whole thing. Yep.
135.
Right, that's a 135. I'm just going to erase that because it gets kind of messy if I don't. Okay, that's a 135. How about if I reflected that dot down here? What would that angle be? Yeah,
225.
225. And what if I reflected it down there? Yeah. 315. Now, based on what we just did for 45 degrees, you should be able to figure out the coordinates for any of those 45-degree angles that are up there. Just imagine taking this triangle and reflecting it. How long is this bottom side? Just the length of it. That's what I want to know. Length of the bottom.
Root 2 over 2.
The length of the bottom is root 2 over 2. And what's the length of the height? Or what's the height? Yeah? It's also root 2 over 2. Each side has the same length. It's just been reflected. So what would the coordinate be for 135? Yep.
Negative root 2 over 2, and then root 2 over 2.
2 over 2. So now if you have to work with a 135-degree angle, that is the coordinate for it. It's negative root 2 over 2, root 2 over 2. All of the 45s are some type of root 2 over 2 and root 2 over 2. They're either both positive, they could both be negative, or one positive and one negative. Just depends on the quadrant that you're in. Okay. So that's why once you know the angle in quadrant 1, doing them in other quadrants, very easy. Okay. Any questions on where the root 2 over 2 is coming from? Okay, so now we want to memorize it. We don't want to have to figure that out again with the Pythagorean theorem. So tomorrow we'll pick up with the 30, 60, 90. This one's a little different because that's scaling. It doesn't have two sides that are the same. So we can't use Pythagorean theorem exactly the same way to figure out the length of those sides. And I want to pretend like we don't remember from geometry the relationships in a 30, 60, 90. Okay, so there is a very simple, kind of clever way we can figure it out. Right, we'll look at that tomorrow. All right, so homework for tonight is going to be on 335. And I want to do also 14 and 22. So I want you to do 1, 5, and 8 in the book, whatever the directions they say. I think they just ask you to find the coordinate. And then I also want you to find the 6 trig functions of 1, 5, and 8. And the 6 trig functions of 3 pi over 2, 2 pi, and root 2 over 2. Okay, so you're going to be finding the 6. So these 1, 2, 3, 4, 5, 6, there should be 36 answers for those. Sine, cosine, the tangent, secant, cosecant, and cotangent. 6 for each of those problems. And then I think these 14 is finding the sines and cosines of a 45-degree angle, and 22 is finding everything else. So there's 6 plus another 6. You should have about 42 answers on the homework, but it's not like it's 42 questions. It doesn't take that long.
Those three, those are, they're not in the book, they're just one thing.
Yeah, the ones after 1, 5, and 8, I made these 3 up. Those aren't in the book. 1, 5, and 8 is in the book, and 14 and 22 are in the book.